Okay, let's jump right in. Today, we're taking a deep dive into something, well, incredibly specific, yet utterly vital for safety on the high seas: onboard welding and hot work operations. We've really gone through a stack of sources for this one, everything from comprehensive safety reports, detailed guidelines, even pre-work checklists, and internal memos about hot work on marine vessels. Our mission, as always, is to sort of extract the most important nuggets of knowledge, giving you a shortcut to truly understand what's at stake here.
Yeah, and what's truly fascinating, I think, is how these guidelines distill really complex engineering principles, years of incident analysis, and just a ton of real-world experience. They boil it down into practical, life-saving protocols. It's really about proactive prevention, not just reacting after something goes wrong, which is absolutely crucial in such a dynamic, an unforgiving environment like the sea.
Absolutely.
Yeah.
And the stakes, honestly, couldn't be higher. We're talking about the safety of the entire crew, the very integrity of the vessel itself, and of course, strict regulatory compliance. This isn't just a routine task. It's like a whole ecosystem of interconnected safety measures. When I first started looking at the sources for hot work, my mind immediately went to fire. What makes that such a prevalent and terrifying risk, especially on a ship?
It's definitely the most immediate and devastating. Our sources really drill down on why. We're talking about the ignition of flammable materials, could be solid, liquid, gas in the immediate vicinity, or critically, even in adjacent compartments you can't see.
Adjacent compartments, wow.
Exactly. This is where that fundamental fire triangle concept comes in. You need heat, fuel, and oxygen. What's crucial to understand is that our job, the hot work itself, creates the heat. So the first, most critical job is to remove the fuel.
Okay, remove the fuel. Sounds simple enough, but how does that translate into, real-world action on a vessel? What do they actually do?
It's meticulous work. All combustible materials have to be either relocated entirely, often to a safe distance, or covered, and not just with anything with certified fire-resistant blankets. And especially in confined spaces, mandatory atmospheric testing for flammable gases is absolutely non-negotiable before anyone even thinks about striking an arc.
Because even a tiny amount could.
Exactly. Even a tiny pocket of vapor could be catastrophic. And of course, a dedicated fire watch is required for all hot work. They're the frontline defense.
Right. Okay, so fire is the big one. Then there's the less visible but equally lethal risk of electricity. High current electrical circuits, especially in damp conditions you find on a ship that just sounds like a recipe for disaster. How do they even begin to tackle something as fundamental as electricity in that kind of environment?
Yeah, that raises a really important question. How do you mitigate such a fundamental risk in such a challenging environment? The guidelines are very clear. Regular inspection and maintenance of all electrical equipment is paramount, just essential. Only equipment with the right insulation and critical safety features, like a voltage reduction device, a VRD, should be used.
A VRD, what does that do?
It automatically reduces the output voltage when the welding circuit isn't actively being used, so it significantly lowers the shock risk during those moments between welds. And personnel must wear dry, insulated personal protective equipment. Dry is key. And here's a crucial detail, something that often gets overlooked. The vessel's structure, the hull itself, must not be used as the return path for the welding current.
Wait, why not use the ship's structure? That seems like the most obvious thing to do, right? The biggest piece of metal around?
It seems obvious, but it's dangerous. Stray currents can flow through the hull, and that can damage sensitive electronic equipment, cause hidden corrosion, or even create sparks in completely unexpected locations. Think about sparks near fuel lines or cargo holds. It's a common shortcut, unfortunately, that the sources explicitly warn against because the potential for widespread, invisible damage is just too high.
Fascinating. Okay, so we've got fire, we've got shock. We often think of those visible dangers, the sparks and shocks, but what about the dangers you can't see or feel until maybe it's too late? I'm talking about harmful fumes and radiation.
Right, and if we connect this to the bigger picture, it's about both immediate protection and long-term health. It's serious stuff. The source material is very, very clear. Welding fumes are classified as Group 1 carcinogens by the International Agency for Research on Cancer, the IARC.
Group 1. What else is in that category?
To put that into perspective, the IARC classifies welding fumes as Group 1, the same category as asbestos.
Wow. The same as asbestos. That's a stark comparison. So what did that classification mean for how these operations are managed? How did things change?
Well, it fundamentally changed how ventilation systems were designed and used on vessels. It really moved things from just basic air exchange to much more targeted fume extraction. Mitigation primarily involves engineering controls like local exhaust ventilation (LEV), which are basically fume extraction units designed to capture those fumes right at the source where the welding is happening.
And if that's not enough?
If those aren't sufficient or can't be used effectively, then appropriate respiratory protective equipment (RPE) is mandatory. Respirators, masks, and for the radiation, you need opaque welding curtains and personal face shields. Those block the intense ultraviolet and infrared radiation from the arc, which can cause really nasty skin burns, we call it arc burn, and serious eye damage, known as arc eye.
Okay, so we've laid out this formidable array of hazards: fire, shock, fumes, radiation. The next obvious question, then, is what kind of defenses are put in place, both for the individual worker and the immediate work environment? What armor and tools do these professionals rely on?
Yeah, the first line of defense is always personal protective equipment, PPE. Our sources make it abundantly clear that certified and properly maintained PPE is completely non-negotiable for anyone involved in hot work.
And what's on that list? What's the essential gear?
It's pretty comprehensive. You're looking at eye and face protection, naturally, like an auto-darkening welding helmet or maybe a fixed-shade shield. For protective garments, fire-retardant boiler suits are mandatory, often with additional protection like leather aprons, jackets, spats for really high exposure areas. Hand protection is critical to dry. Insulated welding gloves, especially with those electrical risks we talked about. And crucially, a suitable respirator must be used if ventilation or that fume extraction isn't doing enough to control those dangerous fumes. You can't breathe that stuff in.
Makes sense. So beyond the gear people wear, what about the environment itself? What workplace safety systems need to be in place?
The sources outline a pretty robust system for the work area. Portable fire extinguishers, specifically the right type for the classifier you might expect, must be immediately accessible, right there. Welding curtains are mandated for area shielding. They segregate the hot work area and protect other people nearby from the arc radiation. And for gas welding, which has its own risks, ensuring gas system integrity is critical. Regulators have to be fitted with flashback arresters, and all the hoses and connections must be leak tested before any use. You don't want surprises with pressurized gas and open flames.
Yeah, definitely not. It's really clear that it's not just about having the right gear. It's about having a systematic approach, a clear plan for every step. This is where the standard operating procedures, the SOPs, really come into play. So what's the absolute first step before any spark can fly?
You've hit on the cornerstone there. Our sources emphasize again and again, a formal completed hot work permit is required before any work begins. And that permit must include a documented risk assessment. It's not optional. As one source clearly states, no hot work begins without a signed hot work permit, no exceptions. They go on. We have assessed the risks, and the permit is our plan to manage them. It's not just paperwork, it's the actual pre-game strategy.
Yeah, non-negotiable step, sounds like. What else is critical before the job even starts?
Well, that permit is complemented by a mandatory pre-use inspection, again, documented. An inspection of all the welding equipment, the cables, the PPE, everything. Imagine this scenario they describe. You're about to start a welding job, and you notice a small crack in one of the welding cables. What is the correct procedure to follow?
Let me guess, you flag it immediately.
Exactly. The answer is clear. Defective equipment must be reported and taken out of service immediately. No cutting corners, no, it'll be fine for this one job. And finally, the work area itself has to be meticulously prepared, cleared of combustible.
How far clear?
Specifically for at least 11 meters, which is about 35 feet, warning signs posted, shielding erected, total preparation.
11 meters. That sounds really precise. Almost
Yeah.
excessive. Why that exact distance?
It does sound precise, maybe almost arbitrary, right? But it's a direct response to past incidents. Incidents where sparks, which people thought were contained, actually traveled much further than expected, maybe carried by drafts, igniting hidden combustibles way over there. The seemingly overcautious rule is a direct lesson learned from catastrophic fires. It taught everyone that just sort of passively assuming things were safe wasn't enough.
Wow, okay. That makes a lot more sense when you put it like that. A hard lesson learned. So once everything's prepped and permitted, there are clear guidelines for the execution, the actual hot work itself. What does that look like?
Well, first, you need a minimum of 2 personnel. The welder, obviously, and an assistant. That assistant also serves as the dedicated fire watch. All equipment must be operated strictly according to the manufacturer's instructions. No improvising. And importantly, Power sources must be de-energized, turned off at the source, and gas valves closed during any period when welding isn't actively happening, even for short breaks.
Why even for short breaks?
It prevents accidental reignition if something bumps the torch or unexpected gas leaks building up. It's about eliminating opportunity for accidents.
Got it. And it doesn't just stop when the welding does. There are critical post-work procedures too, right? You mentioned the fire watch.
Absolutely. This is where vigilance really pays off after the main event is over. The fire watch, for instance, must be maintained for a specified period after work completion. Typically, it's a minimum of 60 minutes.
60 minutes, an hour.
An hour, minimum. To monitor for any smoldering fires, things hidden in insulation or crevices. Our source really emphasizes this, stating, "The fire watch is not a passive observer. You are our first responder." 60 minutes. That's a serious commitment after a potentially long job. You really can't cut corners there. It's almost like watching a delayed fuse you have to monitor.
That's intense. A full hour of just watching.
Yeah.
What else happens after the work is done?
Beyond that critical fire watch, all the equipment has to be shut down properly, disconnected, and stored correctly, put away safely. And the work area must be thoroughly inspected and cleared. All safety signage removed, but only after the area is deemed completely safe by the responsible person. It's really about leaving no stone unturned, no potential risk lingering behind, closing the loop.
Okay, so even with all this meticulous planning, the permits, the gear, the procedures, the fire watch, what happens if something does go wrong? Things can still happen. There's a protocol for that too, right? Clearly laid out in the emergency response protocols.
Yes, absolutely, because you have to be prepared for the unexpected. So in the event of a fire, the immediate actions are cease all hot work immediately, activate the nearest fire alarm, and then, only if it's safe to do so, attempt to extinguish the fire with a portable extinguisher, if it's small and manageable. Beyond that initial response, the vessel's established fire emergency plan must be followed to the letter. Everyone needs to know their role in that plan. It's about rapid response and preventing escalation.
And in the terrifying event of an electric shock, the protocols are very specific there too, aren't they?
Extremely specific, and for good reason. Critically, the sources state, do not touch the victim. That's paramount.
Why? Your first instinct might be to pull them away.
Because if the circuit is still live, touching the victim makes you part of the circuit. You could become a second victim. So instead, de-energize the welding equipment at the source immediately. Cut the power. Then administer first aid if you're trained, and seek immediate medical assistance via the ship's procedures. The guidelines even pose the question rhetorically, what is the most important thing not to do? Clearly emphasizing that direct contact is the worst action.
That's chilling. Knowing what not to do is just as critical.
Absolutely. And, this raises an important question. Beyond all the rules and the equipment lists, what truly creates a safe environment on board a vessel? It connects directly to the idea of a proactive safety culture. It's more than just checklists.
Right. It's not just about individual compliance, is it? It's about the human element. It's about looking out for your teammates, speaking up if something doesn't seem right. That shared responsibility. It's fascinating how a culture can amplify or diminish safety, even with all the best rules in place.
Exactly. Continuous vigilance, unwavering adherence to procedures, even when it's inconvenient, and actively participating in safety briefings. They're often called toolbox talks in the source material, those short pre-job briefs. All of that is paramount for preventing accidents and ensuring the well-being of the entire crew. As our guidelines consistently reinforce, safety is a shared responsibility. It means everyone is an active participant in preventing incidents, not just the designated safety officer or the supervisor. Everyone has a role.
So, wrapping this up, what does this all mean for you listening? Whether you're actually working on a vessel, maybe overseeing operations, or perhaps just curious about how complex safety is managed in these high-risk environments.
I think it's a really powerful reminder. Behind every spark, every weld you might see, there's this meticulously designed system. A system of prevention and response built on countless lessons learned, often hard lessons from past incidents. And it's built on an unwavering commitment to protecting lives. It's really a testament to how seemingly small details, when they're consistently applied and vigilantly monitored, collectively prevent catastrophe.
And here's something to think about. How does the discipline required for hot work safety on a vessel? I mean, everything from that detailed pre-work permit, the 11-meter rule, all the way to that mandatory 60-minute post-work fire watch. How does all that reflect broader principles of risk management? Principles that apply far beyond the shipyard or the ship itself. Consider how these seemingly small, very specific steps collectively safeguard entire operations and, more importantly, lives. It really highlights the absolutely crucial nature of attention to detail, doesn't it, in any high-stakes endeavor.